Hello, everyone. Uh, Thanks for joining my session. Today, I will be talking and discussing about quantum computing. It's an in this world we are in next era where um, there's a requirement of quantum computers. So, what is it? And we'll be going in detail about it. Having said that, quantum computing utilizes the principle of quantum mechanisms like superposition and entanglement to perform calculation, offering the potential for solving complex problems that are too difficult for classical computers. So we'll be doing going in detail about what are limitation of classical computers, and then we'll be talking about quantum computers. What is it, and what are the advantages, and why we need to go for quantum computers. Having said that, making a quantum computers difference and the difference between classical computers and quantum computers. Quantum computers, classical computers uses bits which are either 0 or 1, whereas in quantum computers uses qubits, that is quantum bits, and which can be 0, 1, or both at the same time. And because of the superposition. So we'll be going in detail how what exactly it is superposition and how exactly it works. Moving on, as I discussed about classical computers, and now it's an era of quantum computers. This is a typical representation of classical computer, and we have um, quantum computer representation as well. Chandelier. It's similar to chandelier. And if we talk about difference about, as I discussed, classical and quantum computers, uh, classical computers are one state at a time. You could have many state at a time in case of quantum computers. We'll be going in detail about three things which are around quantum computers. Why we need to go for quantum computers? What are the advantages of going with this transformation and entanglement, superposition, interference? Having said that, as I discussed, it's ultimately playing with bits 0, 1, or both. So bits are independent for each other, 0 or it could be 1. And similarly for qubits, it could be 0, 1, or both, right? Okay. And then how exactly superposition works? If you see, if you toss a coin, either the output could be 0 or 1. The probability of 0 or 1 is 50%, right? And similarly, if you do the measurement and have the same thing, if a possibility of 0 is 85%, then possibility of 1 will be 15%. So that's the distribution which you have as part of positioning, superposition. Then comes superposition, 0 or 1, typically. It could be 15% 0, or probability or 85% and of 1. And going in detail about advantage of quantum computing, massive parallelism, Due to superposition, quantum computers can process a vast number of possibilities simultaneously. That's about massive parallelism. Then comes speed for specific problem. It's because of the speed. That's how mm, we are going for quantum computers. Exponentially faster for certain algorithms. Example, factoring large numbers with the source algorithm. Search with Grover's algorithm. Search, no, these are the famous algorithms. Source algorithm. We'll be talking about it and in subsequent slide. Then efficient simulation of quantum system, natural fit for simulating molecules, atoms, and quantum system. Very hard for classical computers. Then comes application of computing. Typically, as part of cryptography, if you see breaking RSA, encryption, so which is part of source algorithm, then creating quantum safe encryption. This in the field of drug discovery, simulating molecular interaction for to find new drugs. Then comes material schemes, material science, designing new material at the atomic level. Then finance perspective, portfolio optimization, fraud detection, risk modeling. Logistic in the field of logistic, route optimization, routing optimization, supply chain improvement in supply chain and how optimizing route. AI and machine learning perspective, spending up speeding up learning algorithms and quantum enhanced data and analysis. Then comes climate modeling. In this field, simulating complex climate system with higher accuracy. So, simulating complex climate systems with higher accuracy. Then comes in the field of energy, battery design, nuclear fusion modeling, energy grid optimization. So these are the things which you can get details no, about quantum in different fields. Be it be energy, climate, logistic, finance, or cryptography. Okay. And, moving on, quantum solutions. The firm use D waves, quantum annealer, or IBM quiz kit on a quantum simulator to solve the quadratic unconstrained binary optimization. So QO problem equivalent to the portfolio selection task. And as part of this translate the portfolio optimization model into QBO format, then map constraints and objectives into qubit example, minimized variance, stay within the risk tolerance. So minimize the variance and to be between the risk tolerance. Run quantum algorithms like quantum annealing to find optimal or near optimization combination. Then comes compare result with classical solutions, and then comparing with the typically. So, as part of this, let's compare and see what all the metrics like computation time. And in case of classical computing, you will find it will take approximately 10 hours for any task to be processed. But in quantum computing, that gets reduced, optimized to 2 to 5 minutes. Solution accuracy good, comparable, or better. Then comes flexibility for constraint, limited, high, and real time response low, and quantum computing is very high. That's the solution part. Then comes let's have what is that business impact it has. Faster decision making. The firm rebalances its portfolios faster than and competitors. Then better risk management, more adaptive risk modeling under volatile markets. Operational efficiency, reduced reliance on heavy computing infrastructure. Then comes additional applications in finance. In the field of finance, what all the applications where quantum computer is being extensively being used? Fraud detection, faster pattern, faster pattern recognition using quantum machine learning, debating derivative pricing, improving Monte Carlo simulation via quantum accelerations. Risk modeling, more accurate simulation of rare events, tail risk. Market simulation simulates complex market interaction and sentiment dynamics. Conclusion. Last but not least, quantum computing doesn't replace classical finance tools yet, but enhances high complexity computations in ways a classical system can't match. Firms investing in early are building future ready infrastructure for finance. Thank you. Thanks for your time. So I hope you have got at least the gist of quantum computing, which is definitely going to help in going forward. There you could hear a lot of sessions from me as well. And thank you. Thanks for your time.